Module 3 begins. Now, we get precise. In Module 2, we saw the big picture. 5 sectors, 7 assumptions, 4 modes of behavior. But to really understand the model, to simulate it, to apply it, we need mathematical precision. Over the next 6 episodes, we'll examine each component in detail. What are the exact variables? What equations govern their behavior? How do the feedback loops actually work? Today, we start with scope. What does this model include? What does it exclude? And why those choices matter? Let's be clear about what Saylor's model covers. The model describes a closed political economy. 1 state, 1 population, 2 classes. No foreign trade, no immigration, no external shocks except those we deliberately introduce. This isn't because the real world is closed. It's because you need to understand internal dynamics before adding external complexity. Get the core mechanics right first. The model covers wealth creation and distribution, class conflict driven by inequality, social norms that constrain behavior, legislative processes that respond to pressure, executive action that can override normal dynamics, and the feedback loops connecting all of these. The model operates at what we might call the macro-political level. It doesn't track individual decisions. It tracks aggregate behavior of classes and institutions. Think of it like macroeconomics versus microeconomics. We're modeling the forest, not individual trees. What's deliberately excluded? First, foreign relations. No war, diplomacy, trade, or immigration. These matter enormously in the real world, but they're external shocks to the internal system. We can add them later as perturbations. Second, cultural and religious factors. The model treats social norms as a single aggregate variable. It doesn't distinguish between religious authority, ethnic identity, regional loyalty, or other sources of social cohesion. Third, technological change. Production capacity can grow or shrink, but the model doesn't explicitly track innovation or technological disruption. Fourth, individual agency. There are no heroes or villains, no Napoleon, no Washington. The model assumes that individual leaders matter less than structural forces. A bold assumption, but useful for understanding baseline dynamics. Fifth, multiple classes. The model uses Machiavelli's 2-class simplification, rich and poor, grandi and popolo. Real societies have middle classes, professional classes, regional divisions. The 2-class model captures the essential tension but loses nuance. Why these choices? Every model involves tradeoffs. Include more, and you gain realism but lose clarity. Include less, and you gain clarity but lose realism. Saylor chose clarity. He wanted a model simple enough to analyze mathematically, simulate computationally, and understand intuitively. A model with 20 classes, foreign relations, technology, culture, and individual leaders would be more realistic but nearly impossible to analyze. The test isn't whether the model captures everything. It's whether it captures the essential dynamics. Does it explain patterns we observe in real political economies? Does it make predictions we can test? Think of it like physics. Newton's laws ignore air resistance, friction, and quantum effects. They're wrong in detail, but right in essence. They explain planetary motion, projectile paths, and mechanical systems well enough to be useful. Saylor's model aims for the same thing in political economy. Wrong in detail, right in essence. Simple enough to understand, powerful enough to explain. Let's talk about time and space in the model. Time in the model is continuous but discretized for simulation. We measure in arbitrary time units that could represent months, years, or decades, depending on the context. The key isn't absolute time, but relative rates of change. Some processes are fast, executive decisions, market reactions, news cycles. Some are slow, wealth accumulation, norm erosion, institutional change. The model captures these different timescales through different parameter values. Space is essentially absent. The model treats the political economy as a single point. No regions, no cities, no geographic variation. Again, this is a simplification. Real political economies have spatial structure. But adding geography would multiply complexity. The practical implication: when applying the model to real cases, you need to think carefully about what counts as your political economy. A nation-state? A city-state? A region within a larger state? The model can apply at different scales, but you need to define the boundaries. Let me give you an overview of the key variables. We'll explore each in detail in coming episodes. Stock variables, the things that accumulate. W, wealth distribution, the ratio of wealth held by the rich versus the poor. N, social norm strength. How robust are the informal constraints on behavior? L, legislative position. Where does current law and policy stand on redistribution? E, executive power. How much political capital does the ruler have? P, production capacity. What's the economy's ability to generate wealth? Flow variables, the rates of change, conflict intensity. How actively are classes struggling? Norm reinforcement and erosion. What's strengthening or weakening social constraints? Legislative movement. How fast is policy changing? Power accumulation and depletion. Is the executive gaining or losing capital? Growth and decline. Is production expanding or contracting? These variables connect through equations we'll examine sector by sector. Parameters are the fixed values that characterize a specific political economy. Key parameters include alpha, self-interest intensity. How much do actors prioritize personal gain? Beta, norm sensitivity. How responsive are norms to violations? Gamma, legislative responsiveness. How quickly does policy respond to pressure? Delta, executive effectiveness. How efficiently can the ruler convert power into outcomes? Epsilon, production efficiency. How effectively does the economy generate wealth? Tau, various delay times. How long between cause and effect in each sector? Different societies have different parameter values. A society with strong civic culture has high beta. A society with responsive institutions has high gamma. A society with efficient production has high epsilon. Parameters are what make the model applicable to specific cases. Same structure, different parameters, different behavior. Finally, let's discuss the boundaries of the system. Every political economy has limits. Push past them, and you get qualitative change, revolution, collapse, conquest. The model includes boundary conditions, wealth concentration limits. If W exceeds some threshold, revolution becomes likely. The exact threshold depends on norm strength and executive power. Norm collapse threshold. If N falls below some level, the system loses coherence. Rule of law breaks down. Chaos ensues. Executive overreach boundary. If E is depleted too far, the ruler loses control. Coup, overthrow, or fragmentation follows. Production collapse floor. If P falls below subsistence, mass death or migration occurs. The system fails physically. These boundaries define the viable operating region. The model can tell us how close we are to each boundary and what trajectory we're on. That's its practical value. Not predicting exact outcomes, but identifying danger zones. Here's your challenge. Think of a real political economy you want to analyze. Your country, a historical case, or a fictional one. Define the scope. What are the boundaries of your system? What's included? What's excluded? Identify the key variables. What's the wealth distribution? How strong are social norms? Where does policy stand? How much executive power exists? What's the production situation? Make rough estimates. You don't need precise numbers, just relative levels. High, medium, low. This exercise prepares you for the detailed analysis in coming episodes. You're building the target for your model. Next episode, Class Conflict and Social Norms. We examine the first two sectors in mathematical detail, the equations that govern inequality and the constraints that manage it. See you then.